Hello everyone, we are discussing Carnot cycle. And so far I have told you that Carnot cycle, it has four components. Isothermal component starting from A to B, isothermal expansion at temperature T1. We call this temperature of source. Isothermal expansion, volume is increasing. The second component is an adiabatic part running from B to C. From B to C, again you are increasing the volume without supplying any heat. Then you compress it and when you compress it at constant temperature T2. This is isothermal compression. Isothermal compression from C to D at constant temperature T2, which is called temperature of sink. And then finally from D to A, again an adiabatic compression. Now, we are interested in the efficiency of this cyclic process. Which will be represented by eta, alpha, beta, eta. We need this efficiency for the Carnot cycle. What is efficiency? Efficiency is work done by the process divided by heat supplied. Now, this is not total heat supplied, this is heat supplied or accepted by the system. What is this heat supplied and all? Look here. A to B is an isothermal part. Remember these parts. A to B isothermal, B to C adiabatic, C to D isothermal but at different temperature T2, and D to A again an adiabatic part. So when you talk about A to B, let me write everything clearly for you over here. For A to B, it is an isothermal part. A to B isothermal process. If we need heat supplied Q1, then this heat supplied will be nR T1 log VB upon VA. Q1 is nRT log V final A to B. This is final and this is initial. And I did not take the term of U, change in internal energy, because it's an isothermal process. For isothermal, you know that delta U term is what? 0. You can always write delta Q1, but the timing we are interested in the heat supplied, and let's say that is Q1 only, or integration of dQ for that matter. So this much is the heat supplied, Q1. This Q1 is a positive number. Why? Log V final upon V initial. We are dealing with a log of a number which is greater than 1. VV upon VA. Since VV is greater than VA, this log term is a positive number. Or you remember that Q is what? Delta U plus delta W. Delta U is not present, and therefore Q is nothing but work. And we have a statement that when volume increases, work is always positive. So that's what gives you Q1 as a positive number. You need to remember this. For B to C, it's an adiabatic part. No heat is supplied. QBC is 0. I'll call it QBC, which is what? 0. You can call this QAB also. QAB, which is denoted by Q1. QBC, process being adiabatic, is what? 0. Now, for the CD part, which is isothermal portion, everything is same as A to B thing. If I need QCD, I'll call it Q2, which is nRT. Which T? T2. This isothermal compression is at temperature T2, log of V final from C to D. This is the final point. VD divided by VC. V final upon V initial. Since it's an isothermal part, again delta U thing is what? 0. There is no change in internal energy. So delta Q is delta U plus delta W. Delta U is 0. And what you are looking at is simply the formula of work. Right? This is the formula of work. I hope it's clear that the whole thing is what? Negative. Log of a number which is less than 1. VD is less than VC. This is the volume axis. So this VD upon VC is less than 1. Log of a number which is less than 1 is always what? Negative. Or you can say what? For an isothermal component, your heat supplied is equal to work, delta U being 0. When volume decreases, work is always negative. And finally, your Q from D to A is 0, because this is also what? An adiabatic component. CD, A, B, C, D. Note down this much and then we'll talk about efficiency. We have found values of Q1, QDA, QBC and this term Q2 which is coming negative. First note down this information and then we'll proceed further. Now look here. Suppose this Q1 is coming plus 100. It's a positive number, it's coming what? Plus 100. Q2, which is negative, suppose is minus of 80. So what is Q1? 100 and what is Q2? Minus 80. Find out work done by the system for the entire process starting from A to B, then C, D, back to A. For the entire process, find out work done by the system if Q1 is 100 and Q2 is minus 80. Not a single response. I'm asking you work done by the system for the entire cyclic process starting from A, B, C, D, A. Good. These are the three correct responses. Answer is what? 20. कैसे? देखना यहां पर. Let's talk about the complete process. I'm removing this. Remember how do we calculate work and all these things. For the complete process, A, B, C, D, A. A to A. Complete cycle. For complete cycle, delta U is what? 0. I already told you this thing. Any type of cyclic process, change in internal energy is what? 0. Internal energy only depends on what? Temperature. So if temperature at A is T1, when you are back again at A, you have the same temperature T1 and therefore for the entire process delta U is 0. This entire process has two isothermal components. For these two isothermal components individually delta U is 0. There are these two parts for which delta U is not 0, but for the entire process we know that delta U must be 0. For entire process A to A, delta Q means total heat supplied for the entire process is what? delta W, and I'm basically asking you this. Total heat supply delta Q is equal to what? Delta W for the complete process, complete. This delta Q is something which you now know about. What is this? This delta Q is let's use the numbers shown in red. For A to B, 100, which basically is what? nRT1 log V upon VA. Just so that it becomes comfortable, I am using these numbers 100. B to C, 0. C to D, minus of 80, which is basically nRT2 log VD upon VC. And then final adiabatic part, D to A, 0. What is this? For the complete cyclic process A, B, C, D, A, there is no change in internal energy. What is total heat supplied? Total heat supplied is 100, 0, minus 80, 0. There is no change in internal energy, and therefore total work is coming 100 minus 80, that is what? 20. So total work is coming 20. अब आते हैं काम की चीज पर. Look at this efficiency part with the help of numbers first. What is the efficiency of a cyclic process? Work done by the system, 20, divided by heat accepted by the system, or you can say positive heat supplied. Positive heat is being supplied from A to B. C to D heat supplied is what? Minus of 80. Negative sign tells you that heat is getting rejected. System से heat बाहर आ रही है. We will not use this part over here. Total energy supplied is how much? 100. This part. When I say total, this should be all the positive heat given to the system. Why? समझेंगे उस चीज को भी. But work is 20, heat supplied, positive part 100. It gives you an efficiency of 0.2. If you are interested in percentage, multiply this thing with 100 and you get 20% efficiency. In percentage, you can simply multiply with 100 and your result will be in what? Percentage term. So let's multiply with 100 also. If I multiply this thing with 100, what is the efficiency coming? For this particular example, 20%. 0.2 into 100, 20%. What does it mean? इस चीज को फील करना. हमने इस सिस्टम को 100 रुपीज दिए, आपको मैंने दिए 100 रुपीज. Then I told you कि जाओ कुछ परचेज करके ले लो अपने लिए. आपने क्या किया? आपने उससे 20 रुपीज का कोई प्रोडक्ट परचेज किया. लेट्स से यू परचेज अ चॉकलेट ऑफ 20 रुपी वर्थ. नहीं, 20 रुपीज की जो आपने चॉकलेट ली एंड देन यू केम बैक एंड रिटर्न मी 80 रुपीज. दैट मीन्स व्हाट? मेरी तरफ से आपको पूरी फ्रीडम थी कि आप 100 रुपी वर्थ की कोई भी चीज परचेज कर लो, लेकिन आपने केवल कितने का सामान परचेज किया? आपने परचेज किया केवल कितना? 20, एंड यू गेव मी 80 रुपीज बैक. As far as conservation of money और energy is concerned, 100 मैंने आपको दिया, 80 आपने लौटा दिया, तो मैंने आपको 20 दिया, आपने 20 का कुछ सामान परचेस कर लिया. Money is conserved, energy is conserved, but efficiency wise क्या बात चलती है? How much money did I give you? 100. आप चाहते तो पूरा का पूरा 100 यूज करते, लेकिन नहीं, ये सिस्टम उस पूरे 100 को यूज नहीं कर सकता. इसने क्या किया? इसने 80 एनर्जी रिटर्न कर दी. How much did it use? Only 20. So what is the efficiency? 20%. Now first tell me, do you understand why do we take only the positive heat over here? Why do we not take total heat supplied delta Q? Are you comfortable with this part that this Q must be 100, whereas delta Q, which is delta W for the entire system, is 100 minus 80, 20. Yes or no? Write down fast in the comment box. One of you is asking, so please explain the whole thing again. हमने इस सिस्टम को 100 जूल्स प्रोवाइड किया था. Nothing. 80 joule of the heat comes out. No heat is supplied. So the energy which was supplied is 100 joules. Out of this, useful work is of 20. 80 is being rejected. If the system wished, it could have used the entire 100 joules of energy, but it could not. If it could not use the entire energy, then we say that efficiency of a system is work done by the cyclic process, which you also know is area of the cyclic curve. The whole area of the cyclic curve is also what? Work. So this complete area, which is work, divided by whatever energy was supplied, not the total, only the positive part of that energy. Write down the statement for the efficiency part. In efficiency, Q is heat energy accepted by the system. Q is heat energy accepted by the system. That is all the positive values of Q should be taken. Suppose you have a process which has 5, 6, 7 components. Then out of those 5, 6, 7 components, you will only take those components in that Q where term of Q1, Q2, Q3, whatever those are, the terms are coming what? Positive. Whereas delta Q for the entire process A, B, C, D, A, delta Q for the entire process A, B, C, D, A represents total heat inside the bracket accepted or rejected. In delta Q, the delta Q term for A, B, C, D, A is total heat inside bracket accepted as well as rejected. represents delta W or work done by the system or work done by the system inside the bracket, which is also the area of the cyclic curve, which is also the area of the cyclic curve. You can wish, if you wish, you can write like this: A is delta W, which is also delta Q. This much area. Now, note down this, and then I'll erase certain parts and we'll find the efficiency term. So we are interested in what efficiency, which is W upon Q multiplied by 100 for the percentage term. This is coming. What is W? W was coming Q1 plus Q2. Q1 100, the term of delta Q was Q1 plus Q2. It is not Q1 minus Q2. What is Q1 100? What is Q2 minus 80? So if you use minus Q2, that minus minus will become what? Plus. So just be careful. This term of Q1 plus Q2 is what? 100 plus minus of 80. Q1 plus Q2 divided by positive part of the heat, which is Q1, into 100, which is coming Q1 upon Q1 1 plus Q2 divided by Q1 multiplied by 100. What is Q2 upon Q1? Q2 is nRT2 log Vd upon Vc. Q1 is nRT1 log Vv upon Va. So let's find out this ratio of Q2 upon Q1 and then we are going to put it in this function of efficiency. So we are interested in the term Q2 upon Q1. Q2 upon Q1. Q2 nRT2 log Vd upon Vc. Let's save time. So this is coming T2 log of Vd divided by Vc whole divided by Q1 nR cancelled, T1 log of Vb upon Va. Q2 upon Q1 is T2 upon T1 log Vd upon Vc log Vv upon Va. Now we need to find and simplify everything in this. And this is something which I gave you as a homework also when I told you to find a relationship between these things, volumes, pressure, temperatures and all. Now let's see how do we handle this part. A to B It is an isothermal process. B to C, an adiabatic part. At B, you have the volume, information of volume. You have the information of temperature. At C, again, you have the information of what? Volume and temperature. So you can relate volume and temperature. You can relate volume and temperature at A and D and at B and C, and you will get the desired result. For B to C part, I'll be fast. PV gamma, you remember, is what? Constant. So I told you to remember a relation between one of the sets. This is the standard one, PV gamma. Then you replace P with what? nRT upon V. PV equals to nRT. V to the power gamma, which gives us what? T V gamma minus 1. So you can always say that TV gamma minus 1 is what? Constant. So we are using this. Temperature T1, volume VB to the power gamma minus 1 is equal to what? Temperature T2, volume VC to the power gamma minus 1. Again, for D2A, same relation for D2A. D2A, temperature at D, it's part of the isothermal curve. Temperature at this point and temperature at this point, they are same. What is temperature at D? T2. Volume VD to the power gamma minus 1 at A. A is part of this isothermal curve also. A is part of the adiabatic curve as well as part of the isothermal curve. So what is temperature at A? Temperature at A is T1, volume is VA. T1 VA to the power gamma minus 1. क्यों किया हमने ये सब? अब उसके पास चलते हैं. From this and this, you get something like this. T1 upon T2. VC upon VV to the power gamma minus 1. T1 upon T2 is VD upon VA. VD upon VA to the power gamma minus 1. This is coming from these two, which tells us VC upon VB is equal to VD upon VA. T1 upon T2 is equal to this, gamma is same, and therefore VC upon VB is VD upon VA. So we have found interesting result. Do one thing, go down this much fast, go down this everything fast, and then we'll use this information over here and ultimately in the term of efficiency. Go down this fast. Yeah. So this tells us that VC upon VB is equal to VD upon VA. And this whole thing in itself is an interesting and useful result for competitive examinations. In what form? VA, VC, VB, VD. You can write result for competitive examinations. What is the result? VA multiplied by VC multiplied diagonally is equal to what? VB multiplied by VD. Very easy to remember. Look at the diagonal terms. Look at the diagonal terms. Multiply their volumes and they are what? Equal. Now, we are interested in VD upon VC and VB upon VA. From this, I need VD upon VC. VD upon VC. VD upon VC is equal to what? VA upon VB. Now, this is VB upon VA. This is VA upon VB. So you can do what? Or you can do what? You can take the negative sign from the Q2 part common so that it also gives you an impression of the negative thing. Look here, this term of Q2 upon Q1, I can always write it in this form. Negative of T2 log of VC upon VD all divided by T1 log of VB upon VA. So what I have done, this VC upon VD thing, over here is VD upon VC. VD is less than VC. So the number was less than 1. Log of something which is less than 1 is negative. What we have done, we have taken reciprocal of the whole thing and we have taken the negative sign out. This is the property of log. Log of 1 upon 2 is log of 2 to the power minus 1 is minus of log 2. A relation which I think you already know. So when this is 1 by 2, you can write it 2 upon 1, but take the negative sign out. So that's what we have done. And this gives us what? Since VA upon VB is equal to VD upon VC, you're saying that this number and this number, they are now what? Same. And if these numbers are same, you can cancel this term of log with this term of log. And once you cancel these, what do you get? Minus T2 upon T1. This Q2 upon Q1 is ultimately what? Minus of T2 upon T1, and your efficiency is coming 1 minus T2 divided by T1 into 100 in terms of percentage. This is called efficiency of a Carnot cycle. We'll also develop this relation with a shortcut method, but this first method is good because you learn so many different things. The second method which you're going to see is a simple shortcut thing, but this is what is the most important thing if you want to understand what happens in a cyclic process. Now, before we finish the first method, let me tell you what is the importance of Carnot cycle. What is basically expressed by the A, B, C, D, A part. Suppose आपके पास एक source है and source of the temperature of that source is 100 degree Celsius. Let's say steam at 100. Sink a block of ice at 0 degrees Celsius. When you're using T2 upon T1, don't forget to convert these things in what? Kelvin. From 100 degrees Celsius, if you want to transfer heat to a sink, ice, source is what? Box of steam at 100 degree. Sink is what? A box full of ice at 0. So if you want to utilize this heat and all, then maximum useful work which you can get is 1 minus T2, not 0, 273, divided by T1, not 100, 100 plus 273. So this is the maximum efficiency which you can get out of this cyclic process. Cyclic means जिस स्टेज में आपका सिस्टम था, अगर आप वापस उसको वहां लाकर भी छोड़ दोगे, तब भी आपके पास अगर आपने 100 दिया था, लेट्स टॉक अबाउट दैट प्रीवियस एग्जांपल, 100 आपको दिया था, there is no way, Carnot cycle tells us that there is no way if I give you 100 rupees that you can buy something worth 100 rupees. आपको हमेशा उसमें से कुछ ना कुछ पोर्शन वेस्ट ऑफ एनर्जी के फॉर्म में शो करना पड़ेगा. अगर मैं आपको 100 जूल्स दूंगा, there is no way कि आप पूरा का पूरा 100 joules, let's say you want to use that 100 joules in the kinetic energy of this marker. So the point is that 100 joule in no way can be transferred entirely in the form of kinetic energy of mv square. Part of that energy will be lost always. Why? Because whenever you transfer heat from a source, high temperature thing, to a sink, low temperature thing, specialty of the Carnot cycle is that it is telling you maximum efficiency which you can get is 1 minus T2 upon T1 into 100 only. There is no way you can use entire energy in any given process. And that's what I have told you in the previous lecture when I told you things in this form कि हमने फैन से एनर्जी कहाँ ट्रांसफर की? डायनेमो. You can never transfer complete energy from fan to the dynamo. Then you transferred energy from dynamo to the fan. Again, you can never transfer entire energy because efficiency term has a mathematical limit कि आप पूरी की पूरी एनर्जी को कभी भी यूजफुल वर्क के फॉर्म में नहीं यूज कर पाओगे. We'll see the second part also of this second method for this, but if you are comfortable with this 1 minus T2 upon T1, development of this 1 minus T2 upon T1 using all these ratios, adiabatic part and all, then write down yes in the comment box. Look at this second approach. Delta S. What is S? Entropy. Delta S change for A to B. Delta S for A to B is Q1 how much heat did you provide to the system? Q1. This much. Or let's write down this form. QA2B divided by T1. Delta S from B to C is 0. It's an adiabatic component. Delta S from C to D QCD divided by T2, and delta S from D to A is 0. Change in entropy from D to A being an adiabatic component is what? 0. Delta S, delta S, delta S, delta S. Now, delta S for A, B, C, D, A. These are delta S for the 4 components. And this is delta S for the entire cyclic process A, B, C, D back to A. आप जहां से चले थे वहीं आ गए हो. That means आपका जैसा भी sample था, whatever disorderness this thing had, you have brought the whole system back to the same stage. That means your delta S is what? 0 for the entire process. But this delta S has 2 terms basically, this and this. These two being what? 0. Forget about this. What is QA to be? Q1 divided by T1. Second thing is what? Q2 divided by T2. Q2 divided by T2. Now, the moment you say for the entire process change in entropy is 0, for this and this, Q1 upon T1, Q2 upon T2, for this and this, it's 0. क्या चाहिए था अपने को? Q2 upon Q1 मिल गया. Look at this. This tells us that Q2 upon Q1 shift upon is coming what? Minus of T2 upon T1. So if I use the concept of entropy, I can find the ratio of Q2 upon Q1 as minus T2 upon T1. Put it here. It gives you what? Efficiency part. This is a shortcut thing. It doesn't give you the feeling what is happening with pressure, volume and all other things. But to understand the Carnot cycle, you can use this concept of entropy also. Put down this as a second shortcut method. Let me tell you again this thing that we are directly using delta S. We have done everything in the lecture of entropy. It starts with ds equals to dq upon t. So when you integrate, you are integrating the whole thing. A to B part being isothermal gives us an advantage that you can always take T out, and then you are left with integration of dq only. I hope ये चीज समझ में आ रही होगी. T is constant, बाहर आ गया T1. अपने को केवल क्या चाहिए? dq, integration of dq. From a to b, integration of dq gave us what? q1. From c to d, from C to D, everything is at a constant temperature of T2. So this T becomes T2. आपने केवल क्या इंटीग्रेट करना है dq, and its integration is coming what? q2. तो हम शॉर्ट फॉर्म में बिना वो इंटीग्रेट किए हुए पूरा का पूरा फंक्शन, इस एंट्रोपी फंक्शन को यूज कर पाए. होपफुली क्लियर होगा. नोट डाउन दिस. Write down the question. Temperature of source is 100 degrees Celsius and temperature of sink is 0 degrees Celsius. $500 joules of energy is supplied. 500 joules of energy is supplied to the system. Find out work done by the system. Temperature of source is 100 degrees Celsius. Temperature of sink is 0 degrees Celsius. 500 joules of energy is supplied. Out of this 500, how much is the useful work? Answer this. Do one thing. Find out efficiency first and then go for the work part. Now try to understand this. One of you has answered 500 joules. Suppose this question is asked in an objective examination and you find that one option is 500 joules itself, then that cannot be the answer, because you know that efficiency can never be 100%. From 100 to 0, for any type of system, second law tells us that efficiency can never be 100%. If you are transferring energy from high temperature to low temperature thing, high to low, then efficiency can never be 100%. That means if I give you 500 joules of energy, there is no way you can use the entire 500 joules of energy. Some part will be lost to the surrounding, and therefore find me useful work. You guys are taking too long, and I'm asking you a very easy thing. W divided by Q is 1 minus T2 upon T1. I mean, if they are looking for efficiency, you can multiply by 100 in terms of percentage, but W upon Q is the only thing which is being asked, 1 minus T2 upon T1. Now, if temperatures are in degrees Celsius, you can always do this. T1 minus T2 upon T2. What is T1? 100. What is T2? 0. So what is the difference? 100. When you go for the difference, Celsius or Kelvin, it will give you the same thing. Difference. So 100 minus 0 is what? 100 only. What is T2? Oh, this is not T2, this is T1. T1. What is T1? 100. But now you cannot write this as 100. it should be written as 100 plus 273. Again, difference wise, Celsius and Kelvin, they are what? Same. But temperature wise, T1 is not 100, should be 100 plus 273. I'm looking for W. What is Q? Q means the amount of heat given. Question tells you that 500 joule has been given to the system. So this is your 500. Q. W is required, which is coming what? 500 into 100 divided by 373. 500 into 100 divided by 373. Whatever this number is, solve it and you get what? Work done by the process. कुछ खास नहीं करना है, सीधा formula and you can find it. That's it. How much do you understand? Write down the next question. $300 joules of energy is supplied. 300 joules of energy is supplied. Temperature of source is 27 degrees Celsius and temperature of sink is 0. How much heat is rejected by the system? 300 joules is supplied. Temperature of source is 27 degrees Celsius. Temperature of sink is 0 degrees Celsius. Question is, how much heat is rejected by the system? Answer this. Well, you guys are not careful. Again, not able to produce a correct answer, although everything is in front of you. So the second question, W upon Q. How much energy is given? 300. 300 joules is given. T1 minus T2. 27 minus 0. Source is T1, sink is T2. 27 minus 0. Difference wise, you can directly use Celsius. Divided by T1, which is 27. But use 27 plus 273. This and this cancelled. W is coming 27 joules. And everybody is writing 27 joules, 27 joules, 27 joules. But what my question is, I'm asking you how much heat is rejected. I gave you 300 rupees and you purchased an item worth 27 rupees. Then how much did you return me? The heat rejected is 300 minus 27, that is 273 joules. 273 joules heat is coming out. And you all are answering 27, 27, 27. Look at the question. Question says find out heat rejected. 273 is coming out. Do you understand this? 273, yes or no? Right on the last question. temperature of source is 50 degrees Celsius. For the third question, temperature of source is 50 degrees Celsius. Find out temperature of the sink. Find out temperature of the sink so that half of the energy is rejected by the system. Find out temperature of the sink so that half of the energy given to the system is rejected by the system. Answer this fast. यार अब इससे इजी क्वेश्चन तो कोई बना ही नहीं सकता. Only one answer and others are sleeping. The question says, I gave you 1000 joules and system rejects half of it. What I am saying is that W is basically Q by 2. तो अगर आप हाफ रिजेक्ट कर रहे हो इसका मतलब क्या है? जितना मैंने आपको दिया उसका आधा आपने वर्क किया. I hope clear होगा. I gave you 1000 rupees, you rejected half of it, that means 500 rupees. You give it back. How much did you use? The other half, which is 500. So the half you are using and the other half you are returning. This gives us efficiency of 50%. 1 by 2 multiplied by 100. अपने को जरूरत नहीं है. We need what? T2 by T1. So your T2 by T1 for the setup is coming what? Shift 1 minus 1 by 2. That is half. So what is T2? T2 is coming 2T1. 2T1 means 2 into, what is the temperature of source? 50. 2 into 50, which is what? 100 degrees Celsius. 100 degree Celsius. ज्यादातर लोग ये करके आते हैं. आप तो यहां भी नहीं पहुंचे, कोई बात नहीं, लेकिन ज्यादातर लोग ये करके आते हैं. Go down this and then make a cross. 2 into T1. What is T1? 50 plus 273. T1 and T2, they are in what? Kelvin. T2 is 2T1. This is 50 degrees Celsius. Write down in terms of Kelvin. This is coming what? 100 plus 273 plus 273. Something somewhere is creating a problem. My fault. This is not 2T1, this is T1 by 2. T2 is coming. I mean, I hope you are getting my point. This 2 is over here. जहाँ मैंने आपको सेल्सियस का कॉन्सेप्ट दिया हुआ है, तो normally people will produce 25 and some of you have done that. So the logic is, I'll come back to that part again. The theme है उसको कैच करना. This is not 2T1. T1 by 2. T2 can never be 2T1. Temperature of sink can never exceed that of source. Sink means जहाँ heat जा रही है. Source means जहाँ से आ रही है. So T1 by 2, and normally people go for what? 50 by 2, and some of you have done that also. So 50 by 2 gives us what? 25 degrees Celsius, which is not correct. Write down like this and then make a cross. So what is required? T1 is what? 50. 50 plus 273 divided by 2 Kelvin. This is the correct thing. This is temperature in Kelvin. And now convert this thing in Celsius if you wish. So if they ask you temperature in Celsius, your answer will be 25 plus 273 by 2, this much in Kelvin, minus 273, whole thing in what? Degree Celsius. I hope you understand the whole thing. Are you comfortable with this example? The kind of silly mistake normally people commit. Directly divide by 2 is not allowed. The temperatures are in what? Celsius. You need to convert them into Kelvin first and then convert them back into what? Celsius. If you understand this whole thing, then write down yours in the comment box and then you can leave. Thank you very much.